S1, discrete random variables, example 4. In this example, we're asked to calculate the theoretical expectation. That's quite old-fashioned language, but it just means, in theory, what would you expect to get on average? This is obviously in theory, because if you did an experiment with this game, you might not get the expected mean. You might score 4 every single time you played it. But what we're talking about here is what would you, in theory, expect to happen on average. Similarly, we're going to work out the variance. So, looking back in your notes, the formula for the mean or the expected value is this. And so you need to show in an exam what you're doing. Don't just write down an answer just in case you get it wrong. There's only 4 here, so I'll write them all out. Won't take that long. Use the fraction facility on your calculator to type these in, and you should get an answer of 35 over 12. It's fine to leave answers as fractions. If you wanted to change it to a decimal, it's 2.92, but I like to keep things exact because I know I'm going to use this value in the next part of the question. The formula for the variance, again, look in your notes, it's very similar to the variance formula that we did when we had a list of data. Okay, so what that means is you square the value of x and multiply it by the probability. So it's 1 squared times by a 6th. You square the value of x first. 2 squared multiplied by 1/6. 3 squared multiplied by a quarter. And 4 squared multiplied by 5/12. Once you've done all of that, which is this first part of the formula, you then take away the mean squared, and this is why I wanted to keep the exact value. So you then subtract the mean squared. Pause the video and have a go at that on your calculator. Make sure you can get the correct answer. So I got that the first part added up to 39 over 4, and then you're going to subtract 35 over 12 squared. I'm going to work it out as a fraction, but actually because it's the final answer, you could give it as a decimal, and it's 1.24 to 3SF. I'll just make one comment at this stage because it'll help us later on in terms of some notation. This part of this formula here has a piece of notation all of its own. The expected value of x squared. So if you compare it, the expected value of x is x times the probability summed. The expected value of x squared is x squared times the probability summed. So it's just a different piece of notation, but notice how this is not the same as squaring the mean. Those two things are not the same. So the expected value of x squared and squaring the mean are two completely different answers.